find the center of a circle. So we are still looking at the circle as our first conic section. And let's look at some of the properties. I just mentioned them, we didn't write them down. So 1, the coefficient on x squared and y squared are the same. The coefficients on x squared and y squared are always the same. Then 2, it is always a degree 2 equation in x and y, meaning the highest power of x and y in both cases is always a what? Is always a 2. That's why we are saying it is always a degree 2 equation. It's a degree 2 equation. Then thirdly, it must not have a product of x, y. It shouldn't have such a product. If it does, then it's not a what? It's not a circle. So those are some of the key properties we need to talk about of a circle. Others will just come in as applications. Sometimes they can give you examples on loci that form circles. They can ask you, for example, if you have example 1, if you remember locus, they can say if the coordinates of a variable point P are given parametrically as x is equal to 3t plus 1 and y is equal to t squared, find the locus of P. Sometimes they ask you to show that the locus is a circle. If you recall, even complex numbers has locus. So in most cases, they could ask you to show that the locus of the complex number is a circle, or what is the locus of the complex number? What is the complex number when you find out the argument and the moduli and redesign them from the beginning? Then you express them in terms of x and y. And you could see it could deduce an equation of a circle, an equation of a line, an equation of an ellipse, depending on what you have come out with. So they can set a question not directly as a circle, but a question which reduces into a circle. Okay, so according to this question, the solution can be of this form. We have given x is equal to 3t plus 1. So t is equal to x minus 1 out of 3. But we have also seen that y is equal to t squared. So we shall have y is equal to x minus 1 out of 3. All of this is squared, and this gives us x squared minus 2x plus 1 divided by 9. So 9y is going to be equal to x minus 1 squared is the locus of P. Now, according to this locus is not a circle. Why? The coefficient on x squared and y squared are not the same. Actually, y squared is not there. So if we don't have y squared, yet the property says x squared and y squared are always the same coefficients, meaning they are always there. So if they are not there, definitely this is as being a circle. We shall see that that one becomes a vertical parabola when we discuss parabola. So that is how we get loci, if you recall. Another example. Find the locus of a point which moves so that it is equidistant from the origin and yes, our Alima, Habiba.
So
Negative.
I beg your pardon on the first chapter.
On the first what?
Example.
Hey, Habiba, they were asking us to find the locus of the circle. I mean, of the variable point P. And they said it was being defined by the parametric equations. Those parametric equations included x is 3t plus 1 and y is t squared. So I made t the subject from x and I expressed t in terms of x. Then I substituted for t and I squared. When I got the answer, I came up with this equation. This is still the same as x minus 1 squared over 9. So this is the best way how to simply write it. Now, I could not deduce that the locus of P was a circle. Why? Because you have here x squared, this way you don't have x squared. I mean y squared. So you don't have the same coefficients on x squared and the same coefficients on y squared. If they were the same, and there is no x times y, then we would conclude that actually the locus is an equation of a circle. But now, since it wasn't, we can't conclude that. And I also wanted to confirm to you that that locus is for a parabola, which we are yet to discuss after circles in conic sections. Okay, so though it is a vertical parabola, so right now you can't understand it. So that's why at this level I did not say the locus is a parabola. I just said it is the locus of the point P. But when we discuss all conics by UNAB, when the question is set, you should be able to say the locus is a circle. The locus is a parabola. The locus is this, because the equation you've deduced is for the circle, the equation you deduced is for a parabola, and so on and so forth. Okay. Find the locus of a point which moves, which moves so that it is equidistant from a point. You know, sketches are not awarded marks here in pure math, but just some people want to get these things, you know, from illustrations. It is okay. So if I have this as the origin, they have said the locus of the point which moves so that it is equidistant from the origin. So I can assume the point is here, xy. Equidistant from the origin and equidistant from the point -2.
Excuse me, teacher.
Yes, please.
I was saying that there's the locus as the actual formula. Let me say as the actual formula.
The formula depends on the condition given. In the first number, the locus of that number we are looking for is depending on those parameters. So you design the parameters and ideally solve them by substitution. That is why we let t be that in terms of x. Now for this second case, it has a different ideology they have given you. They want you to find the locus using equidistance from the origin to a point P, which distance is the same from a point P to the point A. So in this case, for this second, that is why for a locus, every condition is different. Even in complex numbers you've seen, they can give you to find a locus using argument, give you find the locus using modulus, using twice of modulus, using twice of argument, and so on and so forth. So whatever they command you to use is what you use to find the locus. Okay. Now here they have said, so that the distance PO is equidistant to P distance AP. And they want you to find that locus. We know O has 0, 0 as coordinates. So PO will be the square root of x minus 0 squared plus y minus 0 squared is going to be equal to the square root of x plus 2 squared plus y minus 5 squared. Because these two distances are the same, first square both sides, remove the square root, and we attain x squared plus y squared is going to be equal to x squared plus 2x plus 4 plus y squared minus 10y plus 5. If they said what? If this was a circle, then we would not have lost the x squared and the y squared. But because the x squared and the y squared are the same on both sides, we lose them. So it sees as being the locus of a circle. So what does it become? It becomes, oh, this was supposed to be 4x. So it becomes 4x minus 10y plus 9 is equal to 0, is the locus of P. Which locus of P is a what? Line. I think all of us know that that is a line. Yes, someone has a question.
Isn't that 5 supposed to be 25?
It's supposed to be 25.
Oh, sorry, thank you. This is 25. So 25 plus 9, 4, 29. Eh? Okay.
Excuse me, teacher.
Yes, please.
Pardon, on example
Let it
2.
be x minus 2.
And it would have been minus 2, but this was a negative 2. So it is x minus 2 induces a positive.
Okay, I've seen.
Yeah. Yes, the lady, well, you are saying, Miss, there's someone who has also said something. Pardon. The question said, find the locus of a point P, which moves so that it is always equidistant from point A and the origin. So if P is to move along that dotted line, wherever it will be, the distance from P to O is the same as from O to A. Even if P is here, even if P is here, as long as P is moving, it will be the same distance from the origin up to A. That is why we have said, if you let P be XY, then A be that, then AP is supposed to be equal to PO or OP. Then we use the definition of coordinates geometry to find the distance, and I equated the two distances. Okay. Let's have another one.
Excuse me, teacher.
Yes, please.
Can you please go back to the previous page?
Go back to the previous page. Okay, previous page, where are you? There you go. Also now to remind you about a previous page. Okay. So to remind you also something about how to find Let me first remind you how to find the equation of a circle. If you have 3 points, I remember giving you this example. I already did it. Find the equation of the circle. Or find the equation of a. Sometimes they can say find the locus. Yeah? But anyway, let's just use the equation of the circle. That moves through point. That moves through points 0, 0, negative 1, 3, and 2, 6. So we have our circle. So this circle of ours has a point, maybe 0, 0. Right there. Then it has another point, maybe 2, 6, which is there. Maybe it also has another point, which is negative 1, 3. The variable point is the center, which is equidistant from the 3 points. Now, if you're using the equations of the circle, we can use x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. And this is occurring if the values of the g and f are negative. Whereas one can use x squared plus y squared minus 2gx minus 2fy plus c if the values of g and f are positive. So we can assume. So which one would you like to use from now on? Let us stick to one, I think, all the time. Eh?
The first one.
The first one, okay. So we should always use the first one. Everyone on this group should always use the first one as the equation of the circle. So we have concluded we are using this one all through. So in that case, I will have, if I substitute 0, 0, at a point 0, 0, we shall have c is equal to 0. Because I will have 0 plus 0 plus 0 plus 0 plus c is 0. So it has given us c is 0. So if c is 0, at the point 2, 6, we shall have 4 plus 36 plus 4g plus 12f plus 0 is equal to 0. Do you realize that we get 4g plus 12f is equal to 40 in negative, giving us g plus 3f is equal to negative 10, equation 1. When I use the other point, negative 1, 3, I will have 1 plus 9 minus 2g plus 6f plus 0 is equal to 0. We shall realize 6f minus 2g plus 10 is 0, giving us 2g minus 6f is equal to 10. G minus 3f is equal to 5. Equation 2. I can add Roman 1 to Roman 2. And I confirm a 2g is equal to, when I add, I get a negative 5. My g is negative 5 out of 2. Remember, I told you if it is a positive here, the g's are negative. Definitely they are negatives. Then f, I can substitute negative 5 over 2 minus 3f is equal to 5. This will give us 3f is equal to a negative 5 over 2 minus 5, giving us a negative 15 over 2. So f will give us a negative 5 over 2. So the center is at -5/2 and -5/2. So if they ask us to find the equation of the circle, then x squared plus y squared minus 5/2 times 2x minus 5/2 times 2y plus 0 is equal to 0. I can lose the 2's, and my equation of the circle becomes, is minus 5x minus 5y is equal to 0. Okay, so this is still an equation of the what? An equation of the circle. So we left last week when all those ideas, we have confirmed them. Okay, we even knew how to work backwards and extract out the coefficients. Yeah. Did someone get an example of a circle which had coefficients which are not 1 on the highest degree of x? Yeah. Did someone land on such example? You do know the problem, you don't solve numbers. If you solve numbers, you should be having those examples where it is not just x squared, it is maybe 3x squared, 4x squared. I mean 3x squared, 3x squared, 5x squared, 5x squared. Anyone who has seen such an example?
Excuse me, teacher. For the person who uses the second method, that person gets the center coordinates as positive. Is it okay for them to be positive, yet others are negative?
Is it okay, as in the center coordinates, someone will get them as
Positive. If
positive.
somebody uses the second method, using the
No,
second
what I
method.
understand is that he's going to get positives, but if he gets positives and is using this equation, the main important thing was to find the equation. When you substitute back to get the equation, you'll definitely get the same equation. The purpose was mainly to get the equation, not the center. But if one has it in mind that this is negative G, negative F, or the other one has it as positive G and positive F, then you should investigate and know which one confirms the negative. They should be the same. The answers should be the same. We are getting a -5/2. I missed a negative here. If it's a negative, you will still get a negative. Wait, you see, can you try it out?
Teacher, that's what I did.
Yeah, that's what you used.
Then I got, yes, and then I got the 5 out of 2 for both G and F.
Positive.
Yes. So I'm wondering, in case I'm supposed to write the coordinates of the center.
Then we should ask ourselves, what did we consider when deriving this equation? Did we consider G as positive or negative? Then that means you have to attach the negative. Because it looks like it must be that we must have used thingy. We must have used those G's as negative. Look, let's first expand here and see. If G is positive, then X minus G plus Y minus F. When you square, you must get R squared. So X squared minus 2GX plus G squared plus Y squared minus 2FY plus F squared should give us R squared. So X squared plus Y squared minus 2GX minus 2FY plus C is equal to 0. This is true if and only if the center has been assumed to be having values of G positive. You have GF with a variable point XY. Whereas if G has been assumed to be negative, that's when we use these ones. That is why I've said we should agree on one side. Let us use one side. Because sometimes learners get confused with those negatives. So I think let us stick to the first one. because the second one might confuse us. But in case you have to extract out the center from what? Hey, wait. No. Do you know where the problem is? If I have used the first one, I know it's okay. We are okay. Habiba, I've understood your concern. Remember, to get the center, you don't just consider the G. What do? You divide the negative 2G by negative what? By negative 2. Now, if yours was positive, you are having 5 over 2. You have to divide the 5 over 2 by a negative 2. It has a 2 outside there. So it will give you a what? A negative 5 over 2. Do you remember that condition I talked about? Habiba, do you remember that? That's what that's what we're supposed to use. But like I've said, if it is mixing us, then we use one side. So whenever you're getting the center, remember you divide the coefficient on linear x by negative 2. Okay? So our center should have been a positive, because we are having it as what? As 2 times a negative 5 over 2. So the whole of this, we divide it by a negative 2. And even this other one has a 2 and negative 5 over 2. The whole of it we divide by negative 2. When you divide, you get a positive. So this one straight away gives you the positive. Whereas this one, you'll have to bring in that conclusion of dividing, or the whole coefficient on the linear terms, by negative 2. Have I made myself clear? Your method, the second method, is very okay. It takes you direct to the answer. But the first method, because of the positive up there, it requires analysis, that you divide the whole of this coefficient, the whole of this one. So you substitute the G times the 2, then divide by negative 2. You will get a positivity, which you have. Okay? So the center.
Excuse me, teacher.
Yes, please.
When is it a must to use the second formula?
When is it a must to use the second formula? We have said we use the second formula if and only if G and F are negative. But we have agreed, we had said that let us agree as a class and we use one method. Then if you're using one method, then whenever you want to get the center is always 2gx or 2g divided by negative 2 and 2f divided by negative 1. And whenever the statement here has a negative, it means the center is a positive. The statement there has a what? A positive, the center means what? A negative. So to avoid that confusion, we have said stick to 1, but whenever you want to get the center, you divide by a negative 2. The entire coefficient on x, the entire coefficient on y. All right? Okay. Okay. Let's have a question here. Condition for a line to be a tangent of the circle. Condition for a line to be a tangent to a circle. Now, if you have a circle, when is a line a tangent to that circle? Is what we are looking at. First of all, I may have a line touching the circle. If a line touches the circle, then we say it is a tangent to the circle. Okay? So if this line touches it, then the distance from the center has coordinates x0, y0, And the equation of the line is ax plus by plus c. Then this is 90. And this is the radius r. Okay? So r becomes perpendicular distance from a line. From coordinate geometry, a line is the tangent to a circle if and only if the perpendicular distance from the center to the circle or to the line is equal to the radius. So you can say it's a line, it's a tangent if and only if the perpendicular distance from the center of the circle to the line is equal to the radius of the circle. And thus, it implies that r can be got from the expression for perpendicular distance of a point from a line. You remember perpendicular distance of a point from a line? That equation is given by the equation of the line out of the square root of the squares of the coefficients on the line. This one is what we call perpendicular distance of a point from where? From a line. So after that review, our distance we are looking for is the radius. The perpendicular distance of the radius will be the magnitude of A. Substitute the center plus B plus C divided by the square root of A squared plus B squared magnitude. So they can give you an example. Show that the line x minus 3y plus 3 is 0 is a tangent to a circle whose equation is x squared plus y squared minus 8x plus 2y plus 7 is equal to 0. Yes, Trevor, your hand was up before I can look at the example.
The derived, not getting it.
Eh?
Why are you dividing by a squared plus b squared? The root of a squared plus b.
This is a formula from coordinate geometry. By now, I assume you have covered the coordinate geometry. Backhouse 1.
No.
Backhouse 1.
We haven't.
Habib, Musomira. Even here, we never told. Here we told.
Yes.
Here we told.
Teacher, you. No.
Okay, I'm going to teach that to senior 5s very soon. I think. Are you guys free from 9? Obakari, when I teach it, I will post it on the YouTube. Then you guys can visit. Because those are the first topics in Pure 1. Coordinate geometry. So from O level JBVA. So here we just advance a little and come up with that formula. But if you're saying how I've derived it, man, if I derive it, I would bore the class. But don't worry, it is even in the logbook. That is the perpendicular distance formula. That is where I first stated it here. It's the formula for perpendicular distance of a point from a line. That even if I have a line like this one, from a point like here, A, which is maybe x1, y1, then the perpendicular distance from this line, which line is ax plus by plus c, is equal to 0, then the distance here, d prime, will be the magnitude of ax1 plus by1 plus c divided by root of a squared plus b squared. X1, y1 are the points of the coordinates of the point from where we measure the distance to the line. So you're going to see it best here in an example. Now, if you compare, let us start with our equation here. Compare x squared plus y squared minus 8x plus 2y plus 7 is 0. Compare it with x squared plus y squared plus 2gx plus 2f what? 2fy plus c is equal to 0. You can use this comparison to find the values of the center. Those of us who are not comfortable with dividing by -2. Yeah? Okay? So, if you compare, you'll have what? You'll have a -4 for G, but because this is a positive here, that negative should have been divided off to give us a positivity. But if you're not steady, you just say, don't waste time. It is -8 divided by -2. Then it is +2 on the y divided by -2. You will clearly get your center as 4, -1. And you're comfortable. That is why I've said we can stick to the addition and we just divide all the time by -2. So we have got the center. So they are saying, show that that line is a tangent to the circle. So if it is a tangent to the circle, then the radius should be the perpendicular distance from the center to the line. You know the radius? The radius can be got from where? Square root of g squared plus f squared minus c. The radius is going to be the square root of 4 squared plus 1 squared minus 7, which gives us what? 17 minus 7, so the radius is square root of 10. Now, we go to the formula and show, when we get the perpendicular distance of the center to the circle, do we get root of 10? If yes, then the line is a tangent to the circle. So the formula says ax naught plus by naught plus c out of root of a squared plus b squared magnitude. You realize that our r is going to be, the equation is which one? The equation of the line is x minus 3y plus 3 divided by the square root of 1 squared plus 3 squared magnitude. Substitute the values of the center because it is the point where the distance is measured. You will have magnitude of 4 plus 3 plus 3 divided by root of 10. Wait a minute. Okay, yes, I've got it. Do you realize that up there you're getting 10 out of root of 10? Is it the same as root of 10? Now your knowledge of SADs has to come back. Rationalize the denominator by multiplying by...
Me, teacher.
Yes, please.
What is A and B?
Yeah? Where did I get A and B?
What is A and B?
Kale. A is the coefficient on X, which is 1. B is the coefficient on Y, which is -3. Are we good? Yes, have you seen it?
Okay, thank you.
Yes. Hence, it is true. It is a what? A tangent to the circle. So if you want to conclude, you say, since the perpendicular distance from the center to the tangent is equal to the radius of the circle, or it's the same as the perpendicular distance from the point 4, -1 to the line that is equal to the radius of the circle, hence the line that which has been given is perpendicular or is a tangent to the circle.
Teacher, pardon, I'm not getting you.
I'm saying that if you want to conclude in English, you can say that since the perpendicular distance from the point 4, -1 to the line x minus 3y plus 3 is equal to the radius of the circle, then the line x minus 3y plus 3 is a tangent to the circle. So we remember in the definition I said you just need to prove that the distance r, which is from the center to the tangent, is the perpendicular distance of that line to that point, which is the center of the circle. If you conclude that they are both the same as r, then you have proved that it is a tangent. Okay.
Thank you, teacher.
You're welcome. With that definition, now we can advance and go to what we call the equation of the tangent to the circle. That was just showing, but now they can ask you to find the equation of the tangent to the circle. So we are now in applications. Equation of the tangent to the circle. If this is our circle, then the tangent is here. Now they want us to find its equation. That is our radius. Then if you're to compare C, and this is the center of the circle, then this is the perpendicular that meets the line at a point HK. Then this is our what? Our tangent. Now, either the gradient of the tangent is going to be K minus B over H minus A. Yeah, this could be either the gradient of the tangent, okay. Then, okay, no, this is the gradient of the radius line, not the tangent. Radius line. Then, the gradient of the tangent will be equal to a negative of H minus A over K minus B. Still from coordinate geometry, I hope now you understand. If this is M1 and this is M2, then M1 is supposed to be equal to, M2 is supposed to be equal to a negative 1 over M1. So when I divide this M1 down, the H minus A goes up, the K minus B goes down, but with a negativity. So if you have those two, then you can deduce the equation. Therefore, another condition here is to say since the gradient of the tangent is now known. Yes, please.
So is the gradient of the tangent negative?
It's because perpendicular lines M1 times M2 is equal to -1. You recall?
Yes, sir.
That's why I'm using that. Sorry, I thought people were we are good experts in coordinate geometry, but it sounds like some of you are not. So the tangent passes through the point HK. Now, since we know the equation of the tangent and we know the gradient of the tangent, and the tangent passes through HK, if I want to find its equation, then the equation of the tangent, will be y minus k out of x minus h is equal to a negative of h minus a out of k minus b. Then with this, I can simplify and make y the subject and get the equation. Now, there is another method. Now, can I assume everyone knows differentiation? Everyone knows. There, I don't say that some of you have never covered.
Yes.
Yeah. So here now, let me give you method 2. So that is method 1. Method 2 is using differentiation. Because the circle is a curve, though when you're differentiating a circle, because of its nature of its equation, you use parametric. You use implicit. Do you remember implicit functions? We use implicit functions to differentiate the circle. Now, when you differentiate it, at that point where you want to get the tangent of the circle, then the gradient of the tangent at that point, because the circle has different gradients at different points, but the gradient at that point, which touches the circle of the line, that gradient of the line is equal to the gradient of the circle at that same point. So according to that, you're going to say the gradient of the tangent will be equal to dy dx. At which point? At the point HK. That's why I was saying that if I want to find the gradient of the tangent at this point, let me call this point what? A. I get the derivative function of the circle, then I substitute that point HK. When I substitute that point HK, the value I get is the gradient of the line. Which line is the tangent? Which tangent or which point would be defining the gradient at that point? Then after that, proceed to find the equation of the tangent. So there we are. Our definition is set and ready to be used. But time is flying so fast, we might need an extra time. If you allow, we can get extra time and do some extra work. Otherwise, which are slow. The circle is the widest, followed by the parabola. So I don't know how much we are going to take with the circle. The other option would be I start another conic elsewhere as we run also this one, so that we do not, because I am looking at, we might end at around before 20th or around 15th December. So if we do, our target may fail. I think I shouldn't rush you so fast. Should go a little bit slow so that you understand them. So example, find the equation. Find the equation of the tangent to the circle x squared plus y squared plus 6x minus 2y is equal to 0 at the point 0, 0. Let me use method 2 first. Method 2, I've said we use the method of differentiating implicit functions. When I differentiate the entire circle function, I get 2x plus 2y of dy dx plus 6 minus 2 dy dx is 0. I don't know that people remember this technique. We shall get 2 minus 2y of dy dx is equal to 2x plus 6. dy dx will be x plus 3 divided by 1 minus y. Now, when you substitute, you're supposed to substitute 0, 0. When you substitute 0, 0, you will get 3 out of 1. So this is the gradient of the tangent. So therefore, the gradient of the tangent will be 3. You use the point of contact, yeah? Because if you're to draw a sketch of this, you would see that the circle is like that, then maybe the tangent is here. This is where this is what? 0, 0. So you look for the gradient function at this point for the circle. This is the gradient function. Substitute that point of contact, which is 0, 0. The gradient you get is the gradient of the line. Now, when you get the gradient of the line is the tangent. We can now say y, 0 is also part of the line. X is also passing through the line, is going to be equal to the gradient. So y will be equal to 3x, will be the equation of the tangent. Okay. So let's use also the other method. I don't want people to have only one option, whereby when they are stuck, they're like, teacher never taught that other method. Option 2, can I wrap this part so that we use the same page? I wrap this part.
Yes, you can clear.
Okay. You can have the following. Now for case 2, we need to first find the center of the circle. Remember, we have x squared plus y squared plus 6x minus 2y is 0. I'm using method 1, which I gave you. Remember, to get the center, you divide 6 by -2, divide -2 by -2. You see that our center is -3, 1. We agree? I think we are. Habib, are you okay?
Yes.
Yeah, I think you can see how comfortable this is. So, with that definition, if I have this as my circle, okay. If I have this as my circle, okay. Where is my circle? Okay, if this is my circle, and this is my tangent, then remember I can get the radius from here. If you're to see this, remember this is perpendicular. This could have M1, this could have M2 as gradients. The center we have seen is negative what? -3, 1. The point of contact here is 0, 0. You see? So I can find gradient M2. Gradient M2 will be 1 minus 0 over -3 minus 0, which is a -1/3. Whereas gradient M1 is equal to a -1 out of gradient M2. This will be -1 out of -1/3. And the answer is TD. Do you see that we get the same gradient? So the line will have y minus 0 over x minus 0 is equal to the gradient of the line. So y is equal to 3x is still the equation of the tangent. So whichever method is easier for you, it's what you should take on. Can I have questions? Why are you dividing by -2 to Shime? Shime, were you there last week in the first lessons of circles?
Yes, sir.
And I never mentioned how that comes about.
Maybe I don't still recall.
You remember, but you don't still recall. You man. I've even derived it here. I've said if this is how the center looks like, then you say, and this is the circle. Then this is GF. Then this is XY. To get this distance, it is X minus G, Y minus F, which is here, which gives us the radius. When you expand, you end up coming with this. Now, to go back and look for the center, you divide the whole of this one by -2. The whole of this -2 and F by -2. So you'll get -2G divided by -2, -2F divided by -2. When you divide them by -2, they take you back to GF, which is the center of the circle. Tushime, is that fine? Tushime, answer me.
Sir. Thank you, sir.
You're welcome. So I'm going to give you an exercise on this. You're going to do it. Not so much, it's just like 3 or 4 numbers, but just to confirm that. Yes, please.
Excuse me, teacher.
Yes. Yes, please. Yeah, the lady said, excuse me, teacher. You want me to go back?
Teacher, please step back to the page.
This one, eh?
Yes, thank you.
You want a screenshot? Take it. So the last definition for today is going to be the same idea, but now we want to find the length of a point to a circle.
Teacher, even the page before that one.
There you go. So the length of a tangent from a point I'll send you the write-up of English. Let me straight away. Elizabeth, I want to take screenshots for all the previous pages. Elizabeth, there you go. Someone should always be doing us a favor. You screenshot and share to the group. Okay. Now this part will have some simple write-up, which I will share with the group. And I'm saying if this is the circle, then they want us to find the distance of the tangent from a point. Now, take a look at this. We want to find the distance from this point, P, which is X0, Y0. We have a tangent contact here at T, where it touches the circle. We have the center of the circle. If the center of the circle is, of course, if it's negative G, negative F, then the equation of the circle is x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. So we are assuming we have a circle of that kind. We have a radius of this circle, r. Then we have a perpendicular tangent to the radius. Now we want to find the distance TP, yeah, or PT. We want to find the length of the tangent from a point to the circle. So we want to find distance PT, yeah. So from the triangle PCT, using Pythagoras theorem, PT squared is equal to CT squared plus, minus, this is CP squared minus CT squared or TC squared. But CT is actually radius. So therefore, PT squared will be equal to CP squared minus the radius squared. Do you also recall that the radius can be got from the square root of G squared plus F squared minus C? So if it is squared, you can be in position to go ahead and find whatever you have. Now, also, if we already have the center of the circle, which we all know how to find now, and they have given you the known point whose distance we want to find, then I can find the CP using coordinate geometry, which is square root of x naught plus G squared plus y naught plus F squared as my CP. Therefore, finally, if someone is to get PT, the distance we want, it will be the square root of CP squared, which is going to be x naught plus G squared plus y naught plus F squared minus CT, which CT we saw as radius, which radius we have seen is G squared plus F squared minus C. The whole of this under the square root. But of course, when we deal with numbers, you will not have to substitute like the way it looks here, because there will be figures, they will be easily dealt with. So that gives the length of the circle. So I'm sharing that right up. You'll have it fully in the notes. And I've shared it to you as part of your notes to take a look at. So there you go. You already have it in your notes. So you can download it, and you can always write it down to beef up our notes. So with that, this is very cheap. So let us look for an example. Find the length. Find the length of the tangent from the given point. The given point 0, 0 to the circle, whose equation is x squared plus y squared plus 4x minus 6y plus 10 is equal to 0. Okay. Now remember, if that is the circle, we have the circle like this. We want to find the distance from a point which is 0, 0. We need to get the center of the circle. We need to find also this distance from this point. So this is a point at contact. This is the point at contact T. This is the point P. This is the distance we are looking for. Can call it X. This is R. This can be Y. Y is the distance from the center to the known point. So known point is 0, 0. What is the center? The center is going to be, Habiba, give me the coordinates of the center.
The center is -4. Sorry, -2. 3.
Positive 3. Do we all know how we have got it?
Yes.
Is there a person who has a problem of how to get the center? If you have a problem, get the coefficient on linear x, 4, divide by -2. Get the coefficient on linear y, -6, divide by -2. You'll end up having -2 and 3. So we have the center. It means y squared is equal to x squared plus r squared. The radius can be found. Remember, radius is got from the square root of 2 squared plus 3 squared minus 10. This is 14. I mean 13 minus 10. The radius is root of 3. So I have r. I need to find y. Because this one is -2, 3, you see that y is going to be equal to the square root of, okay, I called them x and y. Okay, I called them capital. Capital Y, capital X. So capital Y will be 2 squared plus 3 squared, which is root of 13. Therefore, when I square, I'll get 13 is equal to 3 plus x squared. Capital X squared will be equal to 13 minus 3, which is 10. Therefore, the distance is root of 10. So whoever wants to use CP, CT, it is okay. Those ones were just for definition purposes. But in case you want to see, it is a very short number, as you can see, as long as you know how to interpret Pythagoras' what? Theorem. And we have that screenshot, and I take a look at another example. Now, there's an interesting example I want us to see. I'm now bringing 2 circles. Example 2. Find the lengths of tangents to the circle x squared plus y squared minus 2x plus 4y minus 3 is equal to 0 from the center. So whoever does not know how to find the center, you're in trouble. From the center of the circle, x squared plus y squared plus 6x plus 8y minus 1 is equal to 0. Very interesting question. You are finding the length of the tangent to the circle, that one, but from where? From the center of another circle. Yeah. So those of us who want to see the sketch looks like this. Now check this out. This is the tangent whose length we are finding from the center of this other circle. This one also has its own radius, remember? It also has, we have to find its distance from this center to this center. Have we interpreted the model? Is everyone okay with my interpretation and the sketches? This
No,
one has
sir.
center 1. No, sir.
Yes,
Okay.
we have not got it.
You've not got it. The question says, find the length. They're asking us to find this distance. Let me call this distance what? M. They're asking us to find M, which is the distance from the center of this circle that comes and touches this circle as a tangent. Find the length of the tangent from the circle. So from this circle 1, circle 2, we are finding the length of this tangent from here at point P. That tangent goes up to the center of another circle, C1. Now, center C1. Now, even if I have not sketched the circle here, then it means I would have got the center C1 from where? From 6 divided by -2 and 8 divided by negative what? Then the center C1 of the other circle where we are originating from the tangent is -3, -4. So one could have just written here -3, -4 without the circle there. But for the model to be drawn by a teacher, I should show you that these circles are existing. Then get the radius of circle 2. Radius R2, let me call it R2, is supposed to be got from the square root. Oh, but I also need to get the center of circle 2. The center of circle 2 is going to be -2 divided by -2. 4 divided by -2. This will give me C2 is 1, -2. So the radius of the second circle, which is the big circle, will be 1 squared plus 4 minus the C, which is -3. This will give us square root of 8. Square root of what? Square root of 8. If it is square root of 8, then what do we have? We shall have, wait, this is, what is the formula for C, for R? It is G squared plus F squared minus C, isn't it? Yeah, so this is our 2√2. Now, if we have R2, we can find C2, C1. We can find this distance. Let me call it capital N. Capital N is equal to C1, C2, which is equal to the square root, coordinate geometry. Remember, C2 we have seen is 1, -2. So we shall have -3 minus 1, -3 minus 1 squared plus -4 minus 2, a negative. You get a positivity squared. This will give us square root of 4 squared plus 2 squared, which will give us 16 plus 2, which is root of what?
20.
Root of 20. So if that is, yes, please.
Teacher, first go back to R2.
Yes.
How did you get +3?
How did I get negative R2?
Yes, that R2 in the square root 1 squared plus 4, then plus +3. I don't know where I got that +3.
And the C, the formula for R is square root of G squared plus F squared minus C. Do you know that?
Yes, teacher.
And then the general equation of the circle is got from what? The general equation of the circle is x squared plus y squared plus 2gx plus 2fy plus c is equal to 0, not so?
Yes,
So
teacher.
when you do the comparison, yeah?
I understand. I see where I got the 3.
Okay.
Thank
So
you.
we are looking for M. So M is going to be the square root of n squared minus R2 squared, which gives us what? 20 minus 8 under the root. And the answer is root of 12, which is equal to 2 root 3 units. Okay, how are we? Are you okay? Hmm? Okay, next week we shall finish circles, hopefully. Though I wanted to talk about just only circles that touch, as I send you their notes and you'll go through them. The definitions of circles touching. If circles touch, then they meet at a point. Someone has a concern? I'm requesting for the recording of the first lesson about circles for more understanding, so thank you. Just immediately you visit my YouTube channel, Rubama Hamza, subscribe, then like it, then go and look for circles. Introduction. I wanted to show you something.
Thank you, teacher.
Yeah. Guys, I've sent notes on circles touching. So I'm going to briefly talk about it before I close. So I want you to read about it. Next time I want to just start with examples. If this is a circle, and this is a circle, and they are touching, or they are touching like this, or like that, you see they can touch like this. They can touch like that. If you see this, one can touch like that, one can touch like that. You see those circular parts which are getting in contact. Whenever the circles are touching, they touch at one point. So they have one point of contact. But someone said an excuse. Are there videos on complex numbers? I think over there, they are there. You check. Someone was saying excuse. So I've sent you right up on touching circles. So if circles are touching, these are circles that touch each other. Circles can touch each other externally. When they touch each other externally, this is how they look like. That is one circle, and this is another circle. You see that? So these two circles are touching what? Each other. If they touch each other, then the line joining their centers is the concern. You have here center 1, you have here center what? This one will have radius 1, this one will have radius what? Now, the proof that they are touching is this. If circles are to touch, then the distance from the center 1 to center 2 is supposed to be equal to the distance R1 plus R2. And of which C1, C2 is the square root of, if this one has x1, y1, this one has x2, y2, then you have x1 minus x2 squared plus y1 minus y2 squared is equal to the radius squared of the two circles. This is when, this is the evidence. They will ask you to show that the circles touch each other externally. So this is external touching. I've sent you the notes, you read through. Then the last one to discuss is internal. If they are to touch internally, yeah, then the distance between the two circles is equal to the difference in the radii of the circles, as I'm going to show you. Now check this one out. All these are simple as long as you get the definition right. Internally, and circles are touching, this is what happens. You will have one big circle, then you will have one small circle. See that diagram? That is the beauty of the whiteboard. So you have a radius for this one. Then you will have a radius for this other one. Maybe the radius for this one. So this can be having radius R1. This is center 1. To this one, center 2 is here. And this is R2. So the distance between the two centers, actually, this is the distance from here up to here is C1. R1 is not there. R1 is here in red. Let me put it in red. So R1 is from the center here to there. That is your R1. This is R1. Now, you see the distance from here up to here is C1. So C1, C2 in this case is equal to radius R1 minus radius R2. That is why I've said the internal condition is the distance between the centers is the difference between the big circle minus the smaller circle, which of course you'll be using the same technique to find the distance C1, C2. So C1, C2 is going from the square root. If this one is at x1, y1, this one can be at x2, y2. So you have x1 minus x2 squared plus y1 minus y2 squared is equal to the difference between the two radii, which is R1 minus R2. You have come at the exact moment we have concluded from. So guys, this knowledge, please go and add it on what I've sent. And I'm also sending numbers to look at. I'll start with those examples in case you fail them. We are sorry for economics as always, but we hope next week we shall finalize the circle. And then we shall be